All right, welcome back. Today we're going to talk about Objective 11.3, describe the properties of urine and how renal function is evaluated. So people have been using urine to be able to figure out if you're sick or not for a long time. I encourage you to observe your urine when you go to the bathroom, and hopefully we're having like a lighter color down here. But the point of this objective is basically like how urine looks, how urine smells, the substances inside of it give us a good idea if the person is healthy or not. So let's talk about what should be in normal urine. Urine is mostly water, 95%, and the other 5% are solutes or dissolved particles. Of that 5%, most of it are nitrogenous waste products, like urea. The body produces urea when it breaks down amino acids. Most of that 5% is urea. Also, uric acid, produced when the body breaks down nucleic acids, and creatine or creatinine. I don't know if you remember talking about creatine phosphate metabolism during the muscular system as a way to produce energy, but basically another waste product that is produced as the body functions. There are also other compounds that are normal in urine in certain amounts, sodium, potassium, etc. If any of those are high, it could indicate the person is sick. So we're going to look at that when we do a urinalysis lab. This table will probably be helpful to you because it tells you like if this substance is high, this is probably the cause. So refer back to this later. And then what should urine look like? Hopefully, it's going to be kind of clear. If it's cloudy, that could indicate that you have a urinary tract infection. That cloudiness is actually like pus or white blood cells. And a yellow color is normal. The yellow comes from a pigment called urochrome that's produced when hemoglobin is broken down. And if you've ever noticed that the it can become darker yellow sometimes, being darker yellow means that it has more urochrome. If you've ever had a strange color of urine, it might be caused by what you had to eat. For example, if you eat like beets or rhubarb, it can cause it to look kind of pink. I once ate a container of beets and then I went to the bathroom and I thought I had started my period early. That is how yellow my pee was. But most of the time, yellow. And the odor. Normally, when you go to the bathroom, you shouldn't really be able to smell your pee. Like it might have some scent, but not too much. And then if you don't flush the toilet or for whatever reason, you'll notice that the odor does get stronger over time. Or if you have like a cat or something like that, that's why you want to be regularly cleaning the litter box. And you're probably familiar with like if you eat asparagus, it makes your pee smell really bad. So food can affect that as well. We want to pay attention to the smell because that could lead us to another sign of disease. For example, if you notice your urine smells kind of like acetone, nail polish remover, that could indicate diabetes. My grandpa realized that one of his cats was actually diabetic from paying attention to how her urine smelled. And then she got treated and she was okay. And the pH. Normal urine is slightly acidic, but depending on what you eat or just like your metabolism, it could become slightly lower or slightly higher, and that can be normal. And then specific gravity is a ratio of the mass of a substance to a mass of equal volume of water. So we're basically comparing the volume of a liquid to the volume of water. If you think about urine, urine is made of pretty much water and some solutes. So if the specific gravity of water is 1, then the normal specific gravity of urine is going to be slightly over 1 because of those solutes. We will do a urinalysis lab that has 3 parts. You'll do chemical test strips that are going to be able to tell you the specific gravity and tell you like the amount of glucose and protein so we can see if that's high or low. You will observe urine to see if it looks normal or not. Is it cloudy? Is it a strange color? And then we'll also do a microscopic examination where you observe it under the microscope and you're going to notice like, are there red blood cells? Are there white blood cells? What's going on? Here are some resources if you're interested in learning more. and please let me know what questions you have. Thank you.